In this video, we're going to tackle one of the most common challenges in programming: what to do when your code just doesn't work. Maybe you're staring at an error message, or just the results are wrong and you can't figure out why. Debugging is an essential skill that every developer needs. So today I'm going to walk through some steps to identify, troubleshoot, and fix issues in your code. Let's look at a simplified example. Let's imagine you're analyzing survey data and running some statistical analyses on it. In this code, you have a couple of survey responses. Now, we want to get the average satisfaction score by location, so we're trying to calculate the average, one for rural locations and one for urban. But something is giving incorrect results. Now, let's walk through the 10 steps you can use when you're trying to debug code that doesn't work. Step number one is to reproduce the problem, and that means that you should figure out exactly what you have to do to get the error to show. It's because sometimes you're working with a complex data flow and it's not clear exactly when the problem shows up and when it doesn't. So you can run the code with, for example, a small set of data to figure out when this error triggers. What are the concrete steps that someone else could run and get the same incorrect results? So this means answering two questions. A, what's the expected output? And B, what's the actual output? Or what's the expected behavior and what's the actual behavior? So for example, in this problem, we could show that print result does not equal what it should. It should equal, for an urban average of 7, and the rural average should be 6. But that's not the responses we get. Step 2 is to use simple print statements. This allows you to inspect the data and figure out where things are going wrong. Let's add some print statements into this code, and as the code runs, it will report to us what it's doing, and that can help us quickly find an error. Now that we've added all these print statements, we can see that the average is mistakenly being divided by 3 instead of by the length of the list, what it should be. Now, we've solved this error, but let's talk about more steps you can use in general to solve your code problems. Step number 3 is to modularize your code. So sometimes you have these huge scripts that are just lines and lines and lines, and it's hard to figure out what's going on where. Modularizing your code, or separating it into functions and files, can really help to figure out where exactly the bug is. At which point is the error appearing? Step number 4 is to look at logs and stack traces. Almost anything that you run is going to be logging action somewhere, maybe from print statements, maybe from loggings, and maybe just from where you ran the script. Sometimes it's somewhere as obvious as the console, and sometimes apps can log to somewhere that's a bit weird, and you might need to look online or into the documentation to see where the log is getting output into. In many applications, or even in code, you can specify where you want the error log to be, and that helps because you can find it very easily. Now, in the scenario we just looked at, there's no log or stack trace because the bug is logical and not about syntax. But many times, even just looking carefully at what the application prints when it crashes points you to the line that's causing the issues. So looking carefully at the print statements, the log, or the stack trace can really help you identify the problem. Step number 5 is to look at the code history. If you're not tracking changes to your code files, then there's no history to compare to, so you can skip this step. But if you are using version control or another way of tracking changes, it's very useful to look at what changed since the last time the code worked. So even a simple git command like git diff will compare the current version of the code with the earlier version that hopefully had the correct logic. So you might notice that a certain line of code changed that may be accounting for what's causing the problem. Step number 6 is to use the internet. So if you're getting an error that you don't understand, Google it. Helpful sites like Google and Stack Overflow and even the larger Stack Exchange network can really help identify what generally causes a given error. This is especially useful when you have an error message that's specific that you can search. Number 7 is rubber ducking. Rubber ducking is a method of problem solving where a person explains their issue or their thought process out loud, even to an inanimate object, in order to gain clarity and insight into the problem. The term comes from a story in the book The Pragmatic Programmer, where one of the authors suggests carrying around a rubber duck and explaining your code or problem to it when you're stuck. Verbalizing the problem can often help you think it through more thoroughly, and that often leads to the solution. So for example, if you talk through the above code and went through it line by line with a rubber duck, you might say, and in this line we're dividing by the length. Oh wait, what's this 3 doing? So that can help a lot to figure out what the problem is. Step number 8 is to use formal debugging tools. Breakpoints let you pause the execution of your program at a specific line, and then you can examine what's going on at that point. And many IDEs like Visual Studio Code, PyCharm, Eclipse have this feature built in. Breakpoints effectively allow you to pause your program in the middle and check what's happening inside all the variables and understand why your code isn't working the way you expect. You can also use breakpoints directly in the code via the pdb package, which will automatically pause the program at that location. So to solve the program with the Python debugger, or PDB, we could step through the code and inspect the values of the variables at each step and figure out where the code starts getting the wrong values. Step number 9 is to use LLMs. I've saved this for the end because while LLMs are very useful, they are also very prone to hallucinations. And it's important to remember that LLMs are statistical models that calculate what word is most likely to come next in a given sequence. And that doesn't necessarily mean they're always great at debugging code. But in this case, let's paste the code into ChatGPT, which is the most popular LLM as of the publishing of this video in 2025. Look, it figures it out right away. That's very helpful. Last but not least, step number 10 is asking for help. It can be very helpful to just ask a colleague or post the program on a forum online, which can often lead to a quick diagnosis. It's important to note that there are guidelines for writing good questions online. For example, showing the expected output versus the actual output, or explaining what you're trying to actually do, because you may be going about it in totally the wrong way. And you may want to look up some of these guidelines, because if you don't, especially if you ask on sites like Stack Overflow, your question might be removed very quickly. Now, before I finish this video, I decided that I wanted to help you remember all the debugging steps that we covered in this video. And so I've created a mnemonic that can help you to remember. The mnemonic is: robots make perplexing errors, debugging helps our logic remain accurate. Now, each step corresponds to a debugging step. So R is reproduce the problem. Start by reproducing the issue so you can observe it happening consistently. What are the expected results versus the actual results? M is for modularize your code. Break your code into functions. Make sure the code is modular so you can test and isolate specific parts. P is for add print statements. Inspect the flow of data and identify where things are going wrong. E is for error logs and stack traces. Look for any output from the program, error messages, logs, stack traces to help you pinpoint where the issue is coming from. D is debugging tools. Use debugging tools like PTB or others to step through the code more precisely. H is history if you're using version control. Check version control history to spot changes that may have caused the issue. O is to look online. Search for issues online because many people may have encountered the same problem and they have identified what the issue is. L is for ask LLMs, so you can ask an AI or a language model for help when you're stuck. R is rubber ducking. Talk through the problem out loud or explain it to someone else to try to figure out where you're missing something. And A is ask for help. Once you've tried everything, don't hesitate to ask for help from colleagues or online communities. This should make it even easier to recall the steps when you're actually debugging.